People, how's everyone doing today? Welcome to another episode of Mastermind Academy. One day we're gonna have a theme song and we'll figure it out, and we'll play it every single time we get on here. But I hope everyone's having a good day. Happy Tuesday. I guess it is. You know, the week feels long already. But happy Tuesday. What's up? Ain't no profit. Yes indeed, here we go. We're gonna get going. Penguins Airlines, good to see you. What's up, Luke? 100% GME, baby. GME for sure. We're gonna talk about that a little bit. A bunch of people have asked me. I tweeted about it today, and a lot of people DM'd me asking me about what it was. I'll give you guys a quick little rundown in a second of what it is for everyone we'll probably have lots of conversations about this over the next few weeks, just for fun. But yeah, what's up, Abon? How are you doing today? What's up, Uber King Kong? Absolutely, we're gonna get into a little bit of test-driven development today. Learn what it is, how to use it a little bit. We'll practice a little bit as well. It'll also lead us into using exorcism a little bit more to solve some problems. Love listening before the show music. Yeah, I mean, I do. Like I said, I found that song on T-Pain's stream when he was telling about the Pizzle Pack, and you know, ever since then I was like, I gotta find it, and I finally found it. Took me way too long, and I will sing my own jingle. We'll make a serious jingle and an intro just for the fun of it. What else do we have to do? You know? What's up, Brendan JC? How you doing? Arcadius, welcome. White Wolf. I told you Elon will take us to the moon. We are going to the moon. What is considered a passing score on the quizzes? That's a great question. So for the quizzes, I'm gonna put out an updated rubric because I never put out a rubric for those things. 70 and up, 7 out of 10. 70 is considered a passing score for those quizzes. I will re-enable them to. I thought they were all enabled to retake, but I'll update it so that you can retake it. Not a big deal. Don't sweat it at all. What's up, Warp 10? How's everybody doing? What's up, lovely loving Gless? I tried to read it without looking at it first. I tried to read it real time, and I almost got it on the first try. Are the concepts you're going to talk about following specific design patterns, or would you need another stream? So design patterns is pretty interesting. We'll probably touch on a few design pattern concepts throughout this course, but most of the design pattern stuff is actually getting folded into the intermediate course. And really, the intermediate course is really going to start, all intermediate courses are really going to start to be the protein and potatoes of all of the courses. Like I'm constantly shifting them and adjusting them to kind of fit into what I think makes the most sense. I think things like that are going to go into the intermediate level, but we will talk about some design patterns. We'll talk about different things like that throughout the process. So if you have any questions while we're going through things, feel free to ask about it. We can touch on these things. We can start an introduction into these things. But you know, there's just so much. There's people coming from so many different levels of aptitude for this stuff. I don't want to throw too much in yet because we're just getting to the part where we're using the code to do things, but 100% we can start talking about that as we start to build more and more things. So real quick, while we're giving people just a few minutes to get in, to get comfortable, get relaxed and ready to learn for the day. Like I said, I've had a bunch of questions sent to me on Twitter about specifically what is all this GME stuff going on, what everyone's talking about. Well, super fast, I'm gonna give you the quickest rundown ever. If you are not at all interested in the stock market, which I generally am not, you know, I have I've been carrying a couple of stocks. I'm playing the long game, you know, not looking to make a ton of money, but just looking to diversify my savings and things like that. You know, just small long-term investments. It's just not my thing. I'm not a huge gambler. But what's happening right now is it's a very interesting game and a very interesting war kind of between, it's not really a war, but kind of a war between some major hedge funds and honestly Reddit. Right now it's kind of a battle of billionaires, but really Reddit. If anyone is not unfamiliar with Reddit, Reddit is a really cool like forum-based site where you can go and post things and get comment and all the other stuff. But it has a pretty thriving platform. There's a specific subreddit called Wall Street Bets, and a pretty popular person came out and basically told everyone that they were doing something called shorting GameStop. If you're familiar with GameStop is, they used to tell you, used to go there to trade in your game stuff, and they would allow you to trade up and have a good time. They're for the players, but they'd give you basically no money. But brick and mortar store where you can go buy video games, video game consoles, stuff like that. They are, not doing so hot, brick and mortar. They're not doing so hot. So there's something called shorting in investments in stock market don't worry about that. All it means is they're betting, companies are betting that the price on the stock will go down, and they can actually essentially make money off of that. And so when this came out, it was almost out of spite. It's pretty much a meme at this point, but basically people said, hey, we don't like that, kinda, and people started buying the stock, causing the price to go up, causing these big hedge funds who were doing the short of the stock, who were shorting the stock, to lose a bunch of money. And it's actually, it causes a cascading effect, which causes them to have to buy more stock to survive and all this other stuff. It's pretty wild. But at this point, the public is basically really screwing over a bunch of hedge funds, which I'm okay with. I'm okay with, but the stock price is going through the roof. It's in unprecedented levels right now for what GameStop is and what it's worth. But it's, hey, this is the stock market. It's a game. It is gambling. I'm not telling anyone to go do it, but it's a pretty interesting thing. Even if you have no desire to spend any money, I would actually go look into what is happening right now with specifically this, because I think it's an interesting look into into the power of the power of the internet, the power of technology, and kind of the way that people can move. It's pretty interesting. It's just a very interesting situation, but I'm having a good time with it. It's causing me a lot of fun throughout my day. My days are super busy. I have a great time dealing with it today. But yeah, it's pretty exciting. Check it out. Like I said, a bunch of people sent me a message like, hey, what's going on with this? Why is everyone talking about it? Essentially that's what it is. This morning the stock was at like 115 bucks. Now it's at like 220 or 217 last time I checked. But yeah, it's pretty crazy. It's pretty nuts. I put $5 in a couple years ago, just toying with it. Spread of income to cash in. Yeah, up $55 so far, 100%. I bought 3 shares yesterday at $86, and now it's at 200 or something. I was like, as someone who doesn't play this game, I am not a stock market person at all. I know I'm familiar with the very basics of it. And it's just been fun for me. Like it's pretty interesting. CEO WSB here can confirm short. Yeah, it's pretty crazy. I have a very important thing to ask. So I'm out of a job. First off, what's up? I am the God. I'm sorry to hear that. For the past few months, I started trading in the stock market, but the fact that I do not have any income at all makes actually not being able to make a lot of money at all. That's fair. That's how much time I need to train myself in order to become proficient in computer engineering. Finally get the certification to become steady. So that's a great question. I am the God. It depends on your current level of acuity and your current level of familiarity with these things already. If you want to become specifically a programmer or a software developer, I think it's going to take a little while. I think it's going to, I'm going to be honest with you, it's going to take a couple of months of intense work, especially if you are mostly doing it on your own. I'd say honestly, to realistically, if you're starting from scratch, I'd say the minimum is 7 to 8 months to kind of go in, again, if you're learning like on your own, like through this process and kind of picking up things on your own. But there are a lot of jobs in tech that don't take that long. You can hop into a desktop support job at a lot of places with no experience. It's not gonna be paying a ton, but it's a good way to have something tech related on your resume, and it gives you the ability to get closer to all the things that you might want to do, and to be able to have a little bit of mobility. You no longer will have to fight hey, I need some experience. That will count as good experience on your resume. But there are a couple of things. We're gonna talk a lot about testing tonight. I think in a lot of places, software testing is a good entry point into this world as well. It's interesting because it's not super easy, but it's a job that people generally will hire entry level people for, and testers for a lot of different things is a good way to also get some good stuff on your resume and to start your process into your tech journey for sure. Thank you so much for the Twitch Prime sub for Jive Turkeys. Welcome, I appreciate it. What's up, VA? How you doing? Market manipulation, 100%. Funding the public, 100%. First off, I did not see this raid. I'm late on the raid. Thank you so much, JMSWRNR. Maybe it's James Warner. Maybe I shot my shot. I took a guess. Is that it? Welcome to the channel. I'm sorry I missed. I didn't hype it up as soon as it happened. I was trying to, answer all the questions, but thank you so much for the gigantic raid. Welcome everyone from James Warner. I'm gonna say it again. I'm gonna go with that. Let's see, James Warner. Sometimes you take a shot and you hit. Sometimes you take a shot and you miss. It's okay. Welcome to the channel. Everyone who came along with James Warner, thank you. First off, shout out to James Warner with the massive massive raid. So, you know, I'm a bad typist here, but I'm gonna do my best here, especially because you're missing some letters in there. But, you know, give you a shout out. One, I hope you had an amazing stream today. What were you doing today? Let me know how your stream went. Let me know what you were doing. I'd love to know. I'm definitely gonna come check you out. I appreciate the raid. But for everyone who's new, we are doing today we're gonna be learning some specific things, test-driven development, and we're gonna be practicing some of the things that we've been learning. Today is day 7 out of 16. This is Mastermind Academy. We run, you know, bootcamp style series for different different engineering concepts that support software delivery. We run one called Tonight is Decoded. This is specifically around software engineering and computer science. We also run one called Pipelines, which is software delivery, automation and infrastructure, DevOps and kind of SRE concepts there. That's Mondays and Wednesdays. And on Fridays, we run one called Horizons, which is a journey into cloud computing with Amazon Web Services. So you can check it out if you want to learn. You know, we always have something going on. We do series on Docker and all kinds of stuff, Kubernetes, all kinds of stuff all the time. You know, that's what we do here. We're here to learn. We're here to ignite passion in technology and to help connect that passion to opportunities and, you know, help people get jobs and stuff. We're going to be partnering with a lot of companies to bring jobs to all of you all as well, so you can, you know, be mobile and get to where you want to be. So that's what we do here on this channel. So thank you again, James Warner, for giving me, you know, for coming over and gracing us with your presence. I appreciate it. 6 hours a day for a month, get you thinking computer language syntax. Yeah, if you have 6 hours a day to commit to it, 100%. 100%. I don't think it'll take you 6 to 8 months if you have 6 hours a day to commit. But get with people. Don't do it completely on your own. Definitely make sure you surround yourself with a community of people who are, you know, who you can ask questions to, who you can get answers from, because that really, really does help. Started studying 2016. Distant learning, but because of my former professor, regress at all. Yeah, it's pretty tough. It's pretty tough to do it on your own. Pseudocode, entry level. Yeah, I mean, if you already have a little bit of that understanding, I actually don't think you have as far to go as you think if you are trying to go with programming. The hardest part about programming is not learning a language. It is learning how to think like a developer, understanding how you use code to solve problems. That is the thing that we're going to try to address here. Once you get that, learning a new language, learning the actual languages and stuff is pretty easy, but just kind of changing, it takes some practice to change the way that you're thinking about problems. It says week 4 is loops. Luke, yes. So no, you're not looking in the wrong place. I did not update that. We dove into loops last week. So we did dive into loops. The reason why, so I need to update it, but we're gonna be writing loops tonight. We're gonna be talking about those things. We're basically taking everything that we've learned so far tonight. We're gonna be learning about TDD, and then we're gonna be practicing problems that's gonna incorporate all of the things that we've learned so far, which is most of the basics. So variables and different data types and functions and loops. We will be enacting all of those things today. So we will talk about those. So if you have any questions while we are, you know, using them to solve real problems, ask away 100%. Yeah, it is. The syllabus is off. I adjusted some things in the syllabus. That's my bad. Also, mathematics is an issue. Nope. I am the God. That is not a problem. You do not need to be. Everyone believes you need to be great at math to be a programmer. Absolutely not. That is 100% not true. Of course, every bit of knowledge helps. So the better you are at it, sure, it'll allow you to do more things. But no, that's not a problem at all. I promise you, that's not a problem at all. Yeah, Penguin Airlines, we are almost halfway done. And that's why we have 3 levels of each of these classes. That's why it's not just this one 8-week course. You can only learn but so much in that amount of time. Do you do any cybersecurity content? Great question. I do not. I personally don't do any. There will be cybersecurity content coming to the channel. I'm gonna have some other experts in different areas come in and help bolster that kind of content, because I want to be, you know, it's a really important topic, but I will not be telling you anything about cybersecurity because, you know, I don't have the discipline to follow those rules. And, you know, I'd rather someone else tell you about those things. And again, somewhere where I need to learn more as well, but not yet, but definitely in the future. She was good working on some funny channel points rewards with TypeScript. I love TypeScript, to be honest with you. I love statically typed languages. TypeScript made JavaScript fun for me, honestly. Oh, dope. Well, all done for, and Lana, amazing. So also welcome. Those are 2 amazing channels. You all know my love for the Alt F4. You all know my love for Lana's channel as well. So it's pretty dope. You know, the whole community is here. I appreciate it. And what profession in tech do you suggest chasing after? That's a tough one. I think that it's interesting because engineering skills are pretty they're pretty transferable, honestly. Like once you really begin to understand what you're doing and why you're doing it, engineering skills are pretty transferable into different things. I'm kind of partial to infrastructure related things in the cloud, so I really love DevOps and cloud computing and stuff like that. I think that's a really good place for both money and for skills that are going to be beneficial far into the future. You cannot go wrong with any type of software development. We will always need software developers, and that's probably the most plentiful market for jobs, but also probably the most competition as well. You can make a lot of money specializing also in something like tonight. We're going to talk about software testing. There are surprisingly not a lot of amazing software testers out there, and really understanding what that is. So we'll talk about that tonight. But yeah. So what do you do? I don't understand DevOps meaning. We'll talk about DevOps in a little bit. I'm going to get us started. We will absolutely talk about some DevOps stuff. Do you do any Ruby content? No Ruby content. I'm sorry. I mean, would I do any Ruby content? Sure. I would do Ruby content. I don't have any scheduled. I don't hate Ruby. If I did do Ruby content, it would only be Ruby on Rails, to be 100% honest with you, because Rails made Ruby great, to be honest. Without it, it's okay. All right, sorry to rate and run. Get out of here. I understand it. Go eat dinner. Whatever you got to do, go have a great sleep. That's the perfect thing to do. I appreciate it. Get out of here. Thank you so much. And I'll definitely drop by your stream for sure. What's up, Mook? Mook me, welcome to the channel. What's up, Control Byte? Welcome as well. Flux, good to have you. Sweet or Sweat. I don't know why I said Sweet. Sweat 95 or Sweth or Sweat 95. Welcome to the channel. Tetsuji. That's Tetsuji. I tried that as well. Thank you so much for the follows. Welcome. All right, so let's get started. Let's get over to the classroom here. I'll give you all the link to the slides. So a couple of drops in the classroom this evening and decoded. Tonight should be pretty chill though. Hopefully we can get through everything. So slides for tonight. Let's make sure they're public. Anyone, oops, share. Gotta be linked. Commands. All right, the slides command is up. I'll also just paste it for you. So if you need slides, exclamation point slides, that'll give you the slides. I also just pasted it in there. That will give you the slides for this evening to run through. Tonight's slides are specifically around test-driven development. I'm going to share with you a repo shortly as well once we're done with this, so that we can go through some practice problems and have a good time. What's up, Big Three Much? Welcome, Friendly Immigrant. It's good to have you. Thank you so much for being so friendly. I guess, you know, I always like to know when people are friendly. Voice of Unreason. I'm sorry that you are unreasonable, but I'm glad you have a voice. Everyone deserves a voice. So welcome to the channel. Thank you all so much for following. Ooh, Penguins Airlines. That is one of the most amazing questions that you could ask. No, I'm gonna tell you that right now. The infrastructure testing and infrastructure testing is difficult to do. There's a lot of reasons why it's difficult to do. We will have that conversation after we go over test-driven development, because that is a very good question. I'm so glad that you asked that. And we'll talk about why it's problematic and why we can be pioneers at it if we spend some time with it. D'Angelo, I'm sorry about that. I know it's late there. I appreciate you for chilling for a little bit. You know, you can always catch it on YouTube, hit exclamation point YouTube, or follow, or it'll be up for 14 days. Come on through and take a look. Go get some rest. Sleep is very important. Go sleep. Sirgo, thank you so much. Or Saigo, thank you so much for the tier 1 sub. Thank you for the love. Congratulations on no more advertisements. I'm proud of you. But thank you very much. I do appreciate the love. Okay, so let's go through it. Let's do it. So intro to test-driven development and software testing. Testing 1, 2, testing 1, 2. This is actually a really important concept that people don't dive deep enough into, to be honest. I really am looking to set up a full excursion, a full at least a 4 to 6 part class on specifically software testing, because it's much bigger than most people get introduced. People get introduced to it on a very light level, kind of all like how we're going to do tonight, but it's a lot deeper than this. So what in the world is software testing? Really, what is it? What is it actually? So software testing, it's a process for evaluating the functionality of a software application with the intent is key here, with the intent to find whether the developed software met the specified requirements. Okay, that's the first piece. I really should highlight that there. You're testing to see if it meets the specified requirements, and it's not, or not, and to identify the defects to ensure that the product is defect free in order to produce a quality product. This is why it's difficult. What you are doing with software testing is you are looking to ensure that software meets the intended output. You're given features to make, you're giving jobs to do, and the goal of a software tester is to figure out if this thing meets the intent, and like the intent of it is to find this thing out, but also you are looking also to meet the intent of what was designed or what was created. That's why it's important for people to have a collective understanding of what you're trying to accomplish, about what these things are supposed to be, because it is difficult to fully flesh out the design of something, or fully flesh out the functionality of something before it's in use. And so the intent of what you're doing and the intent of the thing that you're creating are both important in this use case. All right, so making sure it's as defect free as possible, and that it does what it's supposed to do. Okay, so there are different types of testing, and the first one is manual testing, and this is what you might be thinking of offhand when we talk about software testing. Manual testing is simply testing by hand. So manual testing is simply, hey, let me, you all are developing software, let me come in now and ensure that when I click on this button, it goes to where it's supposed to go. And when I type this in, it does what I expect it to do. And, you know, exploring the page manually, exploring the application manually. This is what manual testing is, exactly what you're thinking about. You know, you go in, you explore the thing, you look for defects in that way. Nothing wrong with manual testing. There's nothing wrong with any type of testing we're going to talk about tonight. Manual testing is very, very important. This is something that you should do, but we shouldn't rely on manual testing. Okay, very important to do, but we shouldn't rely on manual testing. This is where automated testing comes in. So automated testing is the process of testing software using an automation tool that finds the defects. So this might upfront sound to you like there are these tools that exist that will just comb through your applications to determine if there's something wrong. That's not how these things work. That's not how it works at all. Automated testing is the process. It's the process of actually there are things that you have to create actually, but you create test cases to run through automatically so that you don't have to be hands-on to ensure that specific things are happening in your application or your code. This is what we're going to be learning about tonight, this automated testing portion. This part is very, very important. Why do we want to do testing in an automated fashion? Why isn't manual okay? We're people, we miss things. We miss things all the time. Also, it'll be very time consuming for a larger application to check all the things over and over again every time something is changed. And so automated testing allows us to have repeatable ways to do tasks over and over again and to understand what's going on with our application. We're going to learn about the different pieces of this to learn how we can combine the different types of automated testing to be confident that our application is working as intended. That's the goal of all of this, is to have confidence that the changes and things that you're making to your application aren't affecting its functionality, and that things that you're adding are working as they are intended. Thank you so much, Penguins Airlines, for the 2 months. Thank you for the love. Thank you for the, I just get so excited that so many people, you all are getting time of your life back. These 30-second ads are no joke. You click away, you come back in, another ad. So welcome, I love it. Thank you so much, 2 months, so I appreciate it. Also, thank you, Chiz Freak, for the follow. Welcome, good to have you. All right, so automated testing. Here is the first piece of automated testing. To understand these things conceptually is pretty cool. it would be good to have a conversation. These are also good things to have conversations about in interviews. You know, when you're talking about testing or you're talking about something in an interview, understanding the differences between these types of automated tests can be pretty helpful. So, unit testing. Unit testing is a type of software testing where individual units or components of a software are tested. So individual little pieces of your software are tested. The purpose is to validate that each unit of software code performs as expected, okay? The words right there in the title, unit testing tests a individual unit of your code. Oftentimes, this is not a hard and fast rule, but oftentimes unit testing is going to be the testing of a function. Remember what functions are, take it on back. Functions are, they're reusable piece of code. They're reusable snippets of code that are kind of packaged up. They only run when they're called. And generally functions have an input and an output. And so unit testing is writing tests to be able to test the functionality of these specific units, okay? And if you know, the more and more you can be sure that each unit of code does what it's supposed to do, you can be more confident that the entirety of the code base will do what it's supposed to do. So testing individual units, and this is what we're gonna be learning tonight. Unit testing is usually what people are talking about when they're talking about writing tests for your code. If you become a software engineer, if you become someone who's writing code, unit testing is definitely something you'll be responsible for. You're probably responsible for these other types as well, but for sure, unit testing is something that you're gonna have to do. You have an extensive ad blocking system, but hey, I appreciate that you feel I deserve it. But I also want to hear about this extensive ad blocking system for sure. I've seen some pretty elaborate ones before. You know, I mean, even if it's just a pie hole, I do like pie holes a lot. And I thought about setting up one a couple times, but then I opted out of it. Okay, so that's unit testing. The next one, integration testing. All right, so if unit testing is testing the individual units of code, you know, testing those individual functions of your code. Integration testing is a level of software testing where individual units are combined and tested as a group. So now that we can be confident that the individual pieces are working, that doesn't mean that the pieces now work well together. All right, so one piece, we're testing the individual pieces and we can have some confidence on that level, but we also need to test what happens when we bring all of the code together and it's integrated together. So integration testing is that. So when the code is brought together, do the things that we expect to happen still happen? And there are a lot of tools. There are different tools for each of these things that enable good testing here. But integration testing is more so the testing of the entirety of the application and the functionality of the application, where unit testing again is the functionality of these small units of code that may not cover those functions. Are probably broken down into little pieces that serve a very specific use case and don't really take into account the business logic of the application. Integration testing more so takes care of some of that as well. And integration testing can get pretty large, and there's a bunch of ways to go into integration testing, and we'll talk about that. No need to apologize ever. How are you doing, Rivik? Welcome. It's good to have you. Also, Scones for Tea, welcome to the channel. Thank you so much for the follow. Overlord Punk, welcome as well. It is good to see you. Also, Preziuso tried it. Welcome to the channel. So we got two different types of testing that we're familiar with now. Unit testing, testing the individual units of code. Integration testing, testing how those individual units work when they are put together. Okay, and so this is what, you'll hear this a lot. This is kind of what, you know, if you write unit tests, it may work. Okay, if you write unit tests, it may pass. So take a look at this. Maybe our unit tests are testing the bolt on the left. You know, they're testing how the bolt is connected on the left, and it's also testing individually the lock on the right. And we can see, you know, if we test them each individually, things are looking good. Up front, things are looking good. But an integration test will show that the door opens up sideways, or it opens up, you know, horizontally, and that the intended functionality of what we want doesn't really work. And so this is kind of a good example of why both of these things are important. So it's very important. Like, there's nothing. These locks are not installed wrong. These locks are installed on this door. This lock is installed on this door properly. Both pieces are in place. The bolt meets up with the lock how it's supposed to meet up. but it does not serve the purpose. It does not do the thing that it's supposed to do. It does not lock this door at all. And an integration test will usually test that, hey, does the door lock? Is the door actually locked? Can I open this door? That would be the integration test. And ultimately that would test those two individual pieces, but the unit test is making sure each of those individual pieces works as well. So you'll hear this a lot. There's so many examples of 2 unit tests, 0 integration tests. And this is important to kind of understand how to put these things together. The most difficult part of testing, of software testing, is that it's up to you to understand how to get proper coverage and to test the things, to make sure that your code is properly giving you feedback for what you're doing. It's an art form. It's pretty complicated actually to really get good at it. Being able to think in that way is pretty interesting. What's up, Fred Achiever? Welcome. You know, whatever time you can get here is the time you can get here. It's always a good time. So welcome. Whoever made Python needs to be flogged. I mean, you know, Python's fun. You know, Python's, you know, we're gonna learn TDD with Python today because we haven't learned about structs yet in Go. So, you know, but we'll be writing Go after that today. So yeah. So we're gonna go into more testing types. There are other testing things. I wanna tell you what test-driven development is first, and then we're gonna dive a little deeper into some other types of tests. Those are not the only type of tests. We'll go into it a little bit more after this. So last 2 slides, just so we can get away from this, is what in the world is test-driven development? You will hear TDD pretty darn often. What is TDD though? Like what does that even mean? Well, TDD, a lot of words here, but test-driven development is a methodology. So that's the first thing. Break it off. It's not some crazy technology. It is a methodology. It's the way that you do something. But it's a methodology in software development that focuses on iterative development cycles. So we learned about iteration with loops, and you know that you can repeatedly perform a process on something is iteration. So an iterative development cycle where the emphasis is placed on writing test cases before, this is a good word right here, before the actual feature or function is written. This is the key right here, okay? This is the part that's so hard to do. This is the piece that makes it so weird to do. It's an odd paradigm. The good thing is that if you are just starting to learn how to code, if you are learning this right now, this will be much easier for you to do if we start to learn this right now. But it is where you write your tests. So automated tests are code. You actually are writing code. And automated tests are TDD, test-driven development, is you writing that code to test your software before you ever write any software. Before you write any of the feature, you are writing test cases first. You are writing scenarios where your code is being tested before you write any of the software. So the first thing that you should have when you are doing test-driven development is you should have failing tests. So you write these tests, and when you run them, because you don't have any code, because you don't have any application code, any feature code, they should fail. So before you start, you should have failing tests. And you should be able, like, what this will do is it'll get you in the mindset of thinking about how you're gonna solve this problem and what you need to solve this problem. And after you have the tests, now you write your code for the feature to make those tests begin to pass. So, you know, you can iteratively do it. So you write the code to make the first test that you wrote pass, and then, you know, okay, we're good there. And now you take an iterative approach. So now we tackle it again and we add more to our feature to make the next test pass. And, you know, to make sure that the other test that we already have passing is now not failing. And so we are going to continue to make changes to our code base and add to our feature so that until all of the tests that we create are passing. All right. This is the process of test-driven development. Your development is driven by the tests that you write. Now, I shared something in the Google Classroom that dives a little deeper into the return on investment for test-driven development. Some people, I think it's important to note, some people will come and tell you that test-driven development is the greatest thing since sliced bread, and it'll make sure that you don't have any issues when your code goes to production, and everything will work as intended. This is not true. Multiple studies have shown that there isn't any evidence that this will make your code more bug-free. All right, and you may say, oh, then why would you even do this? Well, this methodology, where it is powerful, and I actually think it's a very powerful methodology, and I think it's a really good way to approach some things, is I think it ultimately makes it, I think it does make it quicker for some people, depending on how your brain works, to be able to implement features, and it gets you thinking about how to solve the problem a lot better. It's a different way of solving a problem. I think coming at it from the end is a pretty interesting way of doing it. I find it to be valuable in a lot of use cases, not in every use case. We're also going to see one of the reasons why we are learning this right now is because of this paradigm, especially when you're learning how to code. We're going to be utilizing a service called Exorcism, completely free. I showed it to you already, but they utilize test-driven development for all of their coding challenges. Once you understand what it is, this becomes very helpful because now it's easier for me to help guide you, or for anyone, for engineers to help guide other engineers and help move people to how to figure out something if you can write the test first, because again, you've thought these things out, and it makes it much easier to reference those things to be able to build some software. Okay, it's really nice. I hope that we're going to go through some examples. We're going to go through a whole TDD process, and hopefully you'll see the value of it. And then we're going to dive straight into some exorcism problems to start to practice all the things that we've learned so far. And we're going to use that test-driven development process where, unfortunately, well, it won't be a true TDD process because we won't be writing those tests. Those tests will already exist for us, but we will be implementing code to solve those. So we're going to actually go through a TDD process first, and then the challenges that we do after that will not be that. So yeah. Who has the time to write test cases when the corporate decides they want to use the code yesterday? So high tech redneck, 100%, I'm with you. This is not always the answer. This is just a paradigm that is important to a lot of companies, and people tout it. Not a lot of people truly practice TDD. It is tough to practice TDD because of time constraints. There's a lot of reasons why it might be tough to do this. Really good to know about it though. Really, really good to know about it. Let's see. Isn't Chef declarative? It is. Yes, Chef is declarative, 100%. I wouldn't approach this with unit testing. So because Ruby, Chef has some good you can do some cool RSpec stuff with Chef. We can talk about that one day. You can do some cool RSpec stuff with Chef, but it's hard to test infrastructure. It's easy to test infrastructure code, but hard to test infrastructure. Let's see. Yes, TDD does force you to know the results that you want. It forces you to know the output of what you're making. So 100%. Okay, so let's talk about a few more test items real quick, and then we'll get hands on with it. So some of the other types. So there are two like manual testing and automated testing, two different categories of testing, both valuable. They work well together. You should be doing manual testing. It helps a lot. You should be doing automated testing as well whenever it's feasible. We talked about some different types of automated testing, which were unit testing and integration testing. There are tons of other types of tests. There's automated smoke testing. There's end-to-end testing. So ensuring your application, every bit of your application works end to end. The paths that the user takes to get to certain things is what you can use. I think it's in like I said, I shared something in the classroom that has a bunch of those other things. I want you to be familiar that there are a bunch of other tests that you can do. Also, there are multiple types of, so unit test is kind of, it's testing the code. Integration test, there are kind of two types of integration tests. There are integration tests that do the that you can write in a similar way that you write unit tests, that are testing the outputs and testing the functionality of the actual code that is output. But you can also use tools. There's Selenium. There's a bunch of there's Sauce Labs. There's a bunch of different tools that you can use to also test. To implement automated manual tests. So, going to a site and clicking on a button and then clicking here and then selecting these options, you can automate these things through tools as well. So there is automated manual testing as well, which is really cool. It's something really cool to check out. But yeah, a bunch of that stuff is in there. All good. Tonight, we're going to focus specifically around unit testing. As far as software development is concerned, that's usually where you want to start, being able to test the little pieces of code that you can write. And so the way that we're going to do this is, let me give you all a repo. I just pushed it a little bit ago. Let's hop into Mastermind Academy, host education, and decoded exercise. I just created this like an hour ago to grab. We were going to actually go through some different problems, but I figured we start with this to make it a little bit easier, to make it a little more concise. And I pulled some stuff out of it to make it a little easier to work with. So grab that link, clone this repository, because again, it's going to have some stub files already there and ready for you. Companies will say they're agile, but really they just get it done. That's 100% true. But done correctly, TDD will work for waterfall or agile. Correct. It'll work for whatever you're doing. Most companies aren't really all in on whatever they say they are, you know, agile, DevOps, all this stuff. Most companies can't be that due to, you know, having to put things out to make money in a reasonable amount of time. Some of the stuff is tough, but these are all good values to practice. And again, knowing these things, you can incorporate pieces of these things into any type of workflow to give you some confidence that your things are in fact working. All right, so grab this repo. I'm gonna need to grab this repo as well. Let's see here. Let's go into, I'm gonna open up VS Code. I'm gonna log into my development instance. Let's see here. Is that the right password? No, it's not. I'm gonna log into my remote Linode instance, and I'm gonna clone this repo, and we're gonna set up some space. We're gonna clone it, and then we're gonna get right to it. And we're gonna go through our first iteration of test-driven development. So from here on out, we're pretty much hands-on code for the rest of the evening. I will try to go at a medium pace, and yeah, we should be good to go. All right, so we're in deCoded. That's great. I'm going to get out of this directory, and I am going to git clone, paste this in, and I'm gonna grab these deCoded exercises right here. Whoa, it did not like that. It's going pretty slow. And I'm gonna go into deCoded exercises, and here, oh, whoops, /decoded exercises. And here is the repository that we just had. I'm gonna open this up right here. And so just open it up in your VS Code or whatever your text editor is, however you wanna do it. Just simply open up that folder or just know how to get to it. And we are gonna get started with the TDD. Oh, yes, regression testing, a really good one, Uber King Kong. So regression testing, okay? Regression testing is the act of, it's the process of testing for things that have broken due to changes that have been introduced. So things that have regressed. So things that were working that are no longer working due to the changes that you have implemented. Regression testing is a very interesting concept. The goal is, if you get enough unit testing coverage and you get enough integration testing coverage, theoretically, you will be able to catch things that have regressed throughout the process. This is not always true. This is where manual testing comes in. This is where automated manual testing comes in for sure. But yes, regression testing is checking to ensure that things that were working have not regressed into a state where they're not working. And so again, a lot of the times this is achieved specifically through getting a greater and greater test coverage and understanding the edge cases and the use cases of what you're doing. You should be able to catch regression testing if you are properly testing your application, which is something that you probably won't be doing properly. But yeah, is it reasonable at all to have practical to have repository inside another repository? Yeah, it happens all the time. I've been keeping a repo with my follow along code and notes, but now I'm cloning a new repo. If I clone it into my other folder, will it break things? No, it will not break things. It will not break things. You'll be okay. It might ask. So here's what I would say. At the very end of this class today, there is a .git repository here. There's a .git folder in here that makes this a Git repository. I would delete this once we're done, because I don't know if we're going to add anything to this. Well, pull the code once we're done, and then delete this. There's something called Git Sub Modules. Or you can look up Git Sub Modules. Git Sub Modules is cool. It allows you to access stuff It allows you to manage Git repositories inside of other Git repositories. If you find that is super complicated and you don't understand how that's working, simply we're probably not going to ever update this folder at all. So you can, once we're done today and you pull whatever you pull, you can either delete this, or if you're not going to pull anything from it and you're going to use the code that you wrote, you can just remove it. And the only reason that you might need to do that is because it's probably going to give you a few little like warnings or errors about having another Git repository inside. But yes, Git Sub Modules, like check it out. It's a pretty cool thing. All right. So here we go. Let's get started with a TDD. And so I just created a basic testing repository for you. So in this TDD folder, we got a couple of different things. Ignore the tags and stuff. So there's a README here that just says you're down with TDD. That's all the README says because we didn't really need anything in here. But there's two files in here that you need to worry about. There's this tdd.py, and this is going to be the Python file which we're going to write our actual code. Okay, so tdd.py is where we'll write that, and then there's this tdd test.py, and I gave you some stub code. I gave you some very basic. I gave you the setup to be able to write tests. Now, every language has its own individual testing framework. So the goal right now is not for you to understand everything that you see on the screen here. The paradigm amongst testing is almost the same across the board. Like the understanding of what you are trying to accomplish and the way that you do it is pretty standard across the board. The framework that you use for the different languages, it can be wildly different, to be 100% honest. But again, the concept amongst them is the same. So we are going to go through and learn it with Python, because I think the introduction to this with Python is a little bit easier than the one with Go. Again, especially because we have not learned structs yet. And that's a really powerful way to help with the process in Go. But there is a video in Google Classroom right now that'll take you through the introduction for Go. So if you want to do that later this week or after this, feel free to go through and do a lot of that. So what we have here is a stub file with the stuff that we need, and this is going to help you as well when we get into some exorcism problems. You're just going to get more and more comfortable taking a look at it. So let's break down what you're seeing here. The testing framework in Python is called PyTest. And with unit tests here, there's a couple of different frameworks that you can use. We're going to use the PyTest command to be able to do it. So this file here is the test file will be separate from your main application file. And the first line we have here is just importing the framework that's going to allow us to have the tools that we need to be able to test this code out. Okay. This next line here, we didn't talk about any other imports besides this one up top, but what this line right here is going to do is it says from TDD import star. This file right here that we're going to write our code in is called TDD. And basically what this is going to allow us to do is to pull in the code from the file that we write. It's going to pull everything that's in this file. It's going to pull it in here so that we can use it and so that we can test against it. All right. That's all that line is doing right here. We can import each function individually, but it's going to pull in all the information from this file so that we can use it in here when we're ready to do it. And then I set up a class for you. Don't worry about classes. We are going to get to classes later when we get to the object-oriented programming section of this. But just don't worry about it. Class is kind of like it creates this big object and function. Don't worry about that. But just know that in this class, we are going to write a bunch of tests. And right here is an example of a test that I'm going to show you in a second. And just, yeah, don't worry about the end piece. This is just a setup for you to be able to write your code, and you are going to simply write your code all down in between these two lines. And we're going to go through and do that together. But let's first figure out what we're doing. Remember, we want to write the code to solve the problem before we write any code to solve the problem. So let's read what we have to do. So normally, the feature or the thing that you're going to have to create is going to be much more abstract than this. You're going to have to read through it, and you're going to have to take the job of breaking it down into pieces and knowing what you need to create to make that thing happen. This is a part of learning how to program. This is something that we are going to learn more and more as we get into more practice problems. But right up front, when you're first introduced to this, I don't think that's a good idea. I'm telling you exactly what to solve. And we're going to write tests for these things, and they're unrelated. There are 3 unrelated things, which is also going to make it a little more helpful because we don't have to break things down into a weird thing. So the very first, we're going to have to do 3 different things here. The first one is to write a function that takes in a string and returns its length, returns how long the string is. So that's the very first thing that we're gonna have to do. So we're gonna have to write some test cases to make sure that this thing happens. We're gonna have to write a function that also takes a list of integers and returns the product of every item in list. So product is the product of something is when you multiply all of them together. So we're gonna have to take in a list of integers and multiply it all together and return that product. So we're gonna have to write a test to make sure that the code that does that works. And then we're gonna have to write one that takes in a string and returns a new string with only the letters in the first letters that are in the first spot and the odd indices. So everything that is at an odd number indice. So 1, 3, 5, 7, 9. So we're going back to indexes and stuff. So we're combining a little bit of stuff here, and we're only going to return a brand new string that basically removes all of the even indices except for the very first one. So 3 interesting little problems. They're all different, and we can write some code to learn how to do this. Now, we are only diving lightly into this because, again, testing can get pretty intense, and it's very, very powerful. Like, these testing frameworks are very, very powerful, but we're gonna give it to you at face value so that you understand at surface level what it's supposed to do, and we can kind of start our process from here. We are gonna write tests, and we're gonna explore tests almost every single class from here on out. We'll either be writing a test or exploring existing tests pretty much for every course, from every class here to the end. So don't sweat it too much. If you're having trouble with it today, it's something that you'll get for sure. Doesn't know pi and PLE, but concepts are the same. Oh, yeah, sure, they're the same. Is knowing when exactly to start TDD. Yeah, I mean, yes. Knowing when to start TDD is tough because you need to understand what it is that you're doing for sure. Induces paralysis 100%. I've heard it's a skill that's super in demand. It really is in demand. Okay, so let's kind of get started with this to make sure we have some time to go through some other practice problems. But we don't want to write any code here. We don't want to write any code yet. We want to write tests to do this. Now, I left you one example test to show you the base level of what you can do for testing. All right. 1, we know what the def keyword is, right? The def keyword creates a function in Python. So this right here is a function, and that means this is a function name. So the name of this function is test, no name given. This is just, I adapted this from something else. Great, it's just an example name. We can give this function whatever name we want, and what you want to do is give this function a name that's descriptive of what it's actually testing. So that's not really good here. We need to look at the problem that we have to solve, and then we'll give it a name. And it can take in a value, or maybe it won't take in a value, but yeah, I mean, well, it needs to take in this for now. So it takes in something called self. Don't worry about that. You don't need to change that. It is taking in a value. And then we have some options. So the unit testing framework will give us some things that we can do. The most common thing that we are going to do is create some type of assertion where we want to assert that this thing is what we expect it to be. And this is kind of the base level of understanding. This is not, this is really the surface level understanding of what this thing is. You can get a surprising amount of test coverage doing things this way though, but you will create a lot of these, but this is again, very surface level of what you can do with this. So it says assert equal. Okay, there are a bunch of these functions. These are methods actually, but there's a bunch of these functions that exist within this framework. And assert equals makes sure that the two things that are passed in are equivalent. Okay, so we're gonna pass in 2 things. We're gonna pass in the code that we want to run. So we're gonna pass in that function. We're gonna run that function basically with whatever input it needs right here as the first parameter of this assert equals function. And then we are going to put after that the expected output. So like we said, coding is essentially getting input, doing some processing, and giving some output. And right at the top, all we're going to be doing is asserting that with a certain input, we're going to be asserting that if we pass this input into this function, that we are getting a certain output. And if this is true, and as many of the cases as we can think of, then testing the input and the output of that function can help us believe and help us be confident that our code is doing what we're supposed to be doing. So imagine this. Imagine if we wrote an addition function. All it did was return two numbers added together. And we said, hey, when we run the add function with 5 and 5 passed into it, it should return 10. And these tests will automatically run through and it'll test that. And given the same input, you should always get the same output. Well, not always, but with a pure function, given the same input, you should always receive the same output. And so that's what should happen. And so as long as, every time we make a change to this code, if we test it with the same input, we will likely get the same output. Hold on one second. Let's see. Cool. So what we can do is we can create these different scenarios. We can create as many assertions as we would like to create, okay? Yes, I am missing this after my input, but this is not the input that we're gonna use. We're gonna have to change this. This is just gonna be an example for us to use. You can keep this up top because this is gonna be a good example it'll give you a little framework to kind of copy off of, but let's go ahead and start writing our own. So I'm gonna copy this right here. All right, and I'm gonna comment this back out just so it's here, so it's available. It's okay to, save these things, copy and paste. All right. What's up, True FFX? Welcome to the channel. What's up, Birdie? How are you doing as well? Monique Martins, good to have you. Brain Wiggins, welcome. Scottissimo, thank you so much for hosting. Appreciate it. Thanks for coming through. Haven't seen you in a while. Welcome. It's good to see you. Hope you are having a great day. Let me go back up here to make sure I didn't miss anyone else. Whoa, I scrolled down way too far, way too fast. What's up, Amira? How are you doing? Also, thank you so much for hosting as well. Yeah, and High Tech Redneck, thank you so much for the follow. Sardini, welcome. Just going for the tea, I already got you. Welcome, everybody. It's good to have you. Yeah, we're coding in Python right now. The problems that we solve after this will all be in Go today. So we're gonna get to both today. All right, so let's change this assertion to be able to test something. So the very first thing, let's put it side by side so we know what we're looking for. The very first function, what does it do? Write a function that takes in a string and returns its length. All right, so you start to think, you say, hey, do I know what to do to be able to, do I know how to do that? Do I know how to find the length of something or how long something is? Maybe, probably, we think we know how to do that. It is something that we've learned. So let's write a simple input output function here. So let's first give it a name. Let's say def, let's call it check string length. Okay, that makes sense. Check string length, phenomenal, exciting, very descriptive. People you might know what that is when you see this test. And so now I have a function that is going to have a set of assertions. So it can have more than one. There's only one in here right now, but we can write a set of assertions that are going to test the input and the output of this function. And it's not even just that. You can test much more than just the input and output. Tonight, we're just going to focus on testing the input and the output of these functions. So we are using the assert equals function to say, hey, when we run this function with a string, we should get a certain output. And so what's the name of the function? So we don't know the name of the function right now, but we can start to think about it. We can start to think about, we can start to plan out what our code looks like. And we can say, okay, we're gonna need to write a function that checks string length. So maybe we might call it, maybe we might call that function check length, maybe. And it's okay to change this up later, but we're gonna call this function that we don't have yet. And we're gonna call it with a certain value. So we might say, hey, check the length of maybe, of the word hello, whatever. This is a string, we need to take in any string. So we wanna test the code. We're gonna have to write some code that does it. What happens if we call that function with hello? What should that output be? And so we can count up the letters that are in there, HELLO. So the output, the length of this should be 5. So we are expecting that when we run check length, or when we run whatever function we choose to write, and we pass in the hello input, we should get 5 back. All right, and so this Hopefully that makes a little bit of sense. We're checking, hey, as long as we put in this word, we should get something else out. This checks literally one use case. This does not mean that we can be, I don't think this yet means we can be confident that our function works in any use case. It's very hard to think of all the cases that might exist. This one is a relatively easy one because there just aren't that many scenarios. There are really 2 scenarios, to be honest. Well, there are a couple of different ones, actually, but we can start to put in assertions to make sure this thing is right. But let's start with just this, okay? So I'm gonna save this file really quick. Yeah, I'm gonna save this file really quick. And yes, writes the function that always outputs 5. Exactly, CVA. That's a really, really good. I love it. Exactly. So we have this that says, hey, when we run check length hello, we should always get 5 every single time. So let's go ahead and let's begin to write our code. Well, first, let's make sure we have a failing test. The way that you run a test, again, there's a couple different ways to do it depending on what framework you're using, but we can use the PyTest command to do that. Now, I don't have PyTest installed. So the same way we did some stuff before, we're gonna use pip to install PyTest. And so I'm gonna do pip3. You might just be able to do pip, but pip3 install PyTest. That's all I'm gonna do. And I hope that should work. Let's find out. It should give me the PyTest framework. And it will allow me to execute this now. And all you got to do to be able to run this is to type in, as long as you're in this directory, you just type in PyTest. If you're not in this directory, you can specify where the file is, but just running PyTest will begin to do this thing. And it says, hey, no test ran 0 out of 13. Why did it say that? It's because I'm not in the right directory. Check that out. Remember I said you must be in the right directory. So you need to be able to do that. So I'm actually gonna go into the directory, or I could have specified the file outside of that. It's fine. I'm gonna go into this directory. I'm gonna run PyTest again, just to make sure it's gonna run. And it says no test ran again. That's weird. Do I have to do PyTest? I can check why they did in a second, but what happens if I call it TDD underscore no test ran? So let's look at why no test ran. Let's look at our file, make sure that we're good to go. So we're gonna save this. It is saved. PyTest, no test ran. Let's see here, TDD. All right, so we should get some failing tests first. Why didn't it do this? Let me see, unit test case, unit test main, take self-assert. That looks good. Import unit test, should be still fine. Let's see here. Set.py. Yeah, it should run a single test. Root directory. Hold on, let me look at it in a second. Yes, this is a test. Let me see. Look at it for a second. Class. Oh, it's because I still had it as 2 for test, which is fine. It's fine that it's 2 for test. Should be fine. Hold on, we'll take a look at this in a second. Let me answer your questions first, and we'll take a look at it. At work, we're doing pair programming by default. That's really good. Pair programming is great. You should do that. It's super helpful most of the time. Sometimes we go into mode where one writes the failing test and the other has to fix it. 100% can be quite fun. Yes, this is a really good way. A really, really good way. This is something that I like to do as well. If I'm on a team and I have an understanding of what we need to do to solve the problem, and someone else who's working on it doesn't quite have the problem, writing some good unit tests to help guide them is a really good way of helping them learn, for one, and to be able to give them guidance without giving them answers. It's a pretty interesting thing. Not a great idea. It's hard to run a test. It's on vision. I'm sometimes struggling with getting unit tests to run, especially when I have to import custom code. That's fair. Seems like in Python, imports also execute the code of the module that you're importing. Is there a good way around what, Flux? Seems like Python imports also execute the code of the module you're running. So the import will not automatically execute the code. It shouldn't automatically execute the code of the thing. Like the import itself shouldn't execute that code. it should instantiate a class of it. But yeah, let's see. TGD underscore test at PY is not the value you called. I shouldn't even need to call it what I call it. Yeah, it is. What didn't I have? That's why you have line 12. Yeah, it should automatically go through. Maybe I can make this a actual main function file, but it should still run the test here. Either way, unit test case single set main unit test main. I also don't even need the if main. I can just run unit test main, unit test dot main if I want. But I don't even need it on main. Is import right? Import unit test. The method needs to start with. The method needs to. Oh, yes. Thank you. Yes, it needs to. I think that is right. I think it needs to. So you're saying it needs to actually start with test like this? That's interesting. It might. I haven't. I chose to use Python because I def test. Yeah, there we go. Okay, let's see if that works. There we go. You're right. Thank you for telling me that. As someone who writes much more in Go nowadays than I do Python, that's super helpful. These are the little things that you learn when you are developing on something. These are the real life little things that should have worked, but for the way that this thing is implemented, I must prepend test to anything that I run. Thank you for that. Super helpful. It saved me from having to do some troubleshooting. Thank you for your time. But take a look at this. Before we weren't running any tests, but now we are. And they're failing. So we have written failing tests, all right, before we've written any type of application code. And so we get some output here, and it can be a little daunting to originally read this thing. And it says, hey, we got a name error. First off, check length is not defined. So that's the very first thing that's happening here. It is failing, but it says check length is not defined. And so we get a name error and everything is failing. This is okay. This is a failing test. And before we can get any other failures, we likely need to start to write some code. But right up front, you should do your best to be able to, as many use cases as you can think of, you should be able to put those on paper. We're not going to put them all on paper first. We're gonna do this iteratively. Remember, we said it's an iterative process. And so normally we'd write a bunch and we begin to write code to fix it. We're gonna start with this one test for right now so that we can really enforce some concepts to you. So failed. So let's fix the very first problem of our test. The very first problem of our test that we can start to iteratively fix, I'm sorry, I struggle with that, is check error, check length, not defined. This is a function that is not defined. It doesn't exist. Makes sense because we have not written any code. What happened here? Okay, so what we can do is hop over to our code and begin to write it. So we're gonna be checking for check length. So let's write our first function called check length, okay? So def check length, all right? And now we've created a function. All right, so okay, if we're just trying to just solve this problem, this failing test, saying this thing is not defined, let's now that we've defined it, it guided us. We know that we need a function called this thing because it's not defined. So we've defined the thing that it said isn't working. And now let's run these tests again. So I'm gonna run PyTest again and check this out. We get a completely different error, and this is helpful in help guiding us to where we want to go. And so it says, hey, interrupted, one error during collection. And we get way more output, and it's very, very confusing. And it says, hey, invalid syntax here. You're having some issues. I'm actively leaving things out to show you that these tests will not only tell you when something is wrong, it gives you a bunch of red text, but it also will guide you to what the issue is. Imagine that every time you make permanent changes, every time you go to push code to GitHub because you think you got some stuff fixed, imagine that these tests, we write them once, but they're running very, very often to ensure that things are still working as they're supposed to. You can get really good output like this. So it says, hey, invalid syntax. So we actually have not specified a function properly. Why? Because we need to have a a colon in Python. That's just how Python syntax works. And to have a full function, we need to have something in the function right here. So pass. This is a complete and legal Python function, okay? So I'm gonna write this, I'm gonna run it again. And now we're getting our first kind of actual assertion error. It says, hey, check length takes 0 positional arguments, but 1 was given. And so take a look, keep your eye on the red things. It'll take you a while to be able to really understand errors. We're going to spend a whole week on errors and error handling. So, we're getting the pieces together, but it's saying, hey, it takes 0 positional arguments, but I was given 1. And so start to read these things and start to think about the words that they're saying and how it corresponds to what we've learned so far. We talked about arguments. You know what an argument is. You know that functions, these little snippets of code, these reusable snippets of code that run only when they're called, they take on positional parameters, they take on arguments. And you have to call them with however amount of arguments are defined in the function signature. When that function is declared, you must call the function with that many arguments. And it says it takes 0, but 1 was given. Why is it saying that? Well, let's take a look at the function that we wrote here. All right. We wrote a function that takes in no arguments. This is the function name right here. And inside the parentheses is where you put what things are taken in, what arguments are taken in. We got nothing here, okay? We're not telling it to take in anything, but yet in PyTest, we are passing something in. We are passing in 1 item. So 1 was given, but 0 were expected. So, now we're at the point where we're like, okay, we need to now iterate over this and modify our function. We need to modify our feature to be able to take in a positional argument. So we can say, okay, cool. We're gonna take in a string. And so string for short, we'll just call it str, or maybe that might be a reserved words. And we'll call it, our string. How about this? And remember, this is just a variable, a placeholder for the thing that's going to be passed in. And so now that we have this in here, let's save this and let's run it again. Okay, let's run our test. You should use these tests as a guide to run them over and over again. And we run it again. What's up, Unique ID? How are you doing today? Good to have you. And we run it again and check out our new error. Again, focus on the red. It says, hey, none is not equal to 5. The thing that's on the left of the assertion is the output, is the actual thing that we got. It's the actual thing, and it's not equal to 5, which was expected. So on the left is what we got, and on the right is what was expected. So we got none, but we expected to get 5. Why is that? And so you can say, okay, all right, it's running our function properly. It was expecting to get 5, but it got none. So let's go back and take a look at our code. One of the first things is, actually, no, let's actually do this. So let's actually write the code. So we know how to check the value. We know how to check how long something is, how long a string is, or how long a list is. And so if we do something like print and we do length, we call the length function and we call it on the thing that's passed in. So we call length on our string. Okay, theoretically, this should give us the length of the thing that's passed in. Okay, and if we want, we could check this. We could check this in a file. We could actually put, we could actually at the very bottom of this file, we could say, we could actually run this function. So we could run check length, and we could pass in something like hello. Okay, down here, and we could check this. We could actually run this Python file if we wanted to kind of check it and make sure it worked well. So Python 3 tdd.py, and it prints out 5, and we say, excellent. We're the greatest, whoever did it. We have written the right code. And so now we say, all right, cool. Let's comment this back out, and let's go ahead and let's run our test to make sure it's doing what we want it to do. And you go in and you run PyTest and you say, what? We just saw it. It's returning 5. Why isn't this working? We said it's supposed to have 5. We're checking the length. Why isn't it working? Well, again, we're really enforcing the things that we learned about these different pieces of programming. Think about those functions. Remember, we talked about functions and that what goes on the side of them is scoped only to that bit of code. And so for you to get information outside of a function, you must return it. We are only printing it. You got it. we're only printing it, you must return the value. Whoa. Okay, you must return the value instead. So we're finding the length, but we're not doing anything with it. It's not actually passing the data around. So instead of printing it out, we are going to return this value out of the function, okay? We're going to simply return it out of the function. So now that we have this, we say, okay, I think this is going to give us our data back. One, notice that we actually got some standard output. So it actually did print. Capture standard output call. It went to standard output, print. Remember, displaying output. Those print functions go to standard output. It goes to the console, but the function doesn't output that value though. It just prints it out. It doesn't actually output the value. Let's, now that we're returning it, let's go ahead and let's check this. Let's check it. All right. So we're on PyTest again, and you now have your very first passing test. Okay. Phenomenal. Very, very exciting. It says one passed. If we had more, it would tell us that more were there. Tune's got me typing and bobbing. Hey, that's why the tunes are here, getting the groove, feeling good. But yeah, green does feel good. Green feels, lets you know that things are great. I want you to know though, that because we tested this does not mean this function always works. Now, this function probably works, but it does not always work. How did I make it terminal colorful? I did not do anything to make this terminal colorful. This is, first off, I don't even know what shell I'm using. I'm logged into my Linode VPS. I have not done anything. It probably has to do with the version of Bash or ZSH you're using to make that happen. It's probably a bunch of settings. One day, and maybe we'll do it this Saturday as a part of the build series. Maybe we should dive into getting all of the cool things set up. This is not even set up with the way that I like to set things up. This is complete, pretty, for the most part, besides the theme, pretty stock. I have some pretty intricate setting changes to make it really nice. And so it could be my VS Code theme, but I don't think so. I don't think the VS Code theme affects the terminal output, but maybe it does. Maybe I'm wrong. Maybe it does. But yeah, I don't know. Okay, so our test did pass, but I think VA said this before. So the thing that we're trying to test against, you got to be careful with this, because we can change the whole thing. We can make the whole thing pass as is, like this. Instead of returning the length, we can simply return 5. And if we run PyTest, this is a passing test. This is a completely passing test right here. Not hard at all. And it can lead you to believe that this is working as intended, but this is not working as intended. It's not at all working as intended. And so that's why you want to add tests to have coverage. You want to cover the different use cases. And so yes, right now this test will pass for the given use case, but that's why it's helpful to have more than one use case. And so we can say, okay, cool. We checked for the assertion of hello and equals 5, but if we added another one, we can say, okay, but what if we pass in, hello world? Well, what should that be? 5, the space is actually 1 as well. So 6, 7, 8, 9, 10, 11. So this should be 11 characters. So we can say, oh my gosh, I'm not used to not being in Vim, to be honest. So it's kind of weird clicking on stuff. So hello world should have an output of 11. Okay. And we run this test. It will run a test on both of those. And generally, if you split these up into different functions, it'll tell you that some passed and some didn't. This is all the same test. So right now it's checking that 5, the 5 is the output that we got, but it's not equal to 11. But the first one did in fact pass, but because of the way we wrote it, it's weird. You got to be careful with what you're doing, because if you don't have proper test coverage, you may feel like what you're writing is correct, but there may be different use cases and things that make it different. And so let's add it back in, and let's take the length of our string, and we should be good to go here. So now if we run this again and we're actually doing what we're supposed to do, we can test this and everything's good to go. Now what we can do is, what about other use cases? What happens if someone passes in something like, let's make a whole new function here. So right here, we're testing check string length. And so maybe we want to write a new test that says, hey, test, check, maybe like empty value. Okay. So now you want to check, you never know how people are going to use this thing. And so now maybe we want to check, and we do a self dot assertion equals. And so these are the different options that you have: almost equals, count equals, contains, a bunch of different stuff in here. There's a bunch of stuff that you have in here. But we're gonna assert that equals, and we'll call check length. But what happens when you don't call anything? What should the output be when you don't get anything? When you don't pass anything, the output should be 0. And really, there are probably 2 options that you could have here, but the output should be 0. And so you can check this here. And that's the use case. And so maybe we'll also do, we'll start with that. We'll start with that. And we'll run it, and we get a failure, okay? It says type error, missing one required positional argument, our string. And so this is where you're gonna have to start to be, what is almost equal? Almost equal is where you can kind of set specific ranges and stuff, I'm pretty sure. I've never used almost equals in Python, but in other languages, you can set a kind of level of play, a level of a play that it can be off of the given amount. But yeah, it's a pretty interesting thing. So check this out. We have one passing. This little dot here shows that we want to have one passing and one failing. And so here is where you have to start to think about how your application is going to be implemented. Okay, this is some of those design patterns we were talking about. Well, these are design decisions and architectural decisions of the application. So if we're checking the string, are we going to implement stuff into our code that says, hey, a string must be presented, you must pass in a string? Are we going to handle that? Or is there a use case when nothing could be passed in? And so are we going to have to handle that? And so this is where your test can guide your implementation. This is where your test guide the implementation. And so if I keep this test, it says, hey, maybe we can pass in something with an empty value. And so if we want to do that, we can change our code accordingly. I wouldn't recommend this, to be honest, but just I want you to learn something new in Python. So maybe we write check for empty value, and we do both of these use cases. We do completely empty and an empty string. One way we can solve this, yes, we could do error handling and instead ensure that an error is passed back. But we could also do some stupid stuff like this, and you can actually do something where you can set default values in a Python function. So this is, I don't recommend doing this, to be honest. Not 0. So what we do is, this syntax right here in Python, this is something new for you, just to learn something new here, is that you can pass in a function, but you can give a function, you can give a default value. You can give a default value for the placeholder that's put in there. And if you pass something in, it'll override this value. But if you do not pass something in, it will take on this default value, which is an empty string. Okay. And now if we run this, we have 2 passing tests. Why? Because when it gets passed in, even without the empty string, that gets assigned as the default value. So, oh, you did stick around for a long time after you said you were going to sleep. So please go to sleep. I appreciate that. Thank you so much for the love and for sticking around, having a good time with us, but definitely go relax. But now we have a passing test, just like that. We got a passing test and we're good to go. So we can be confident this thing is going to work however we decide to use it. So maybe if you want to put in something like, maybe if you even want to do something much longer, and you might want to say self.assert equals, and we go check length again. And maybe we want to do an even longer string. Maybe we want to do something like, maybe we want to pass in a variable like, I'm not gonna do that right now, but let's say we want to do something much longer, which is something like this. I have no idea how many letters are in there, but we're about to check it out right now. And and you might want to go through first and make sure this is a thing. And you might say, all right, let me open this up. And I can jump right into the Python interpreter. And I can go, whoops, I don't know why I did that. Python 3, and I do length of this. Oh, okay, actually, that's good then. Let's do that. Let's do a URL. and there's 58 there. So we can take that, and instead we can put that in there, and this should come back with 58. All right, and we can just, just add in a couple options to make sure things are set up the way that we want them to be set up. Great, very, very exciting. Not really, but we can save that here, and we can have a couple different test cases, just to make sure things are going well. Run our test, not print 3, PyTest. We got invalid syntax, check empty. So see, I added some changes. I made some changes and I broke it. This is why tests are valuable. What's up, Fraud is Good? Welcome to the channel. Or Fraud is Good. Welcome. Thank you so much for the Twitch Prime sub. I appreciate it. Thanks for the love. But I got a problem here. Invalid syntax for test, check empty stuff. So I did something wrong down here. And so when I added in new code, I made I made an error here, and I should probably look at what the error actually is. Invalid syntax on def check empty self values on line 14. That probably means there's an issue with the line above it, to be honest. It's a missing quotation. That seems wrong. Okay, just a missing quotation point mark there. And let's see if it still works. And now it works. So we're good to go. Everything is good. Okay, let's go ahead now that we've been introduced to our first type of test. Let's go ahead and introduce tests for the next two, okay? To make sure that we have a full test file doing all the stuff. So we've solved our first problem. The next one, write a function that takes a list of integers and returns the product of, why does it keep going away? Of every item in list. Okay, and so I'm gonna make this verbose. There's some easier ways you can do this, but let's start talking about this yet. Let's start implementing the things that we've learned. So one, we are taking in a list of integers. A list is a collection, and it's also iterable. So let's write a function. Actually, no, we don't want to do that. What we want to do is we want to write some tests. Okay, so we want to write some tests here, and we want to say, test underscore. We're checking for a product of numbers, and we're gonna say check product. I'll just call it check product. Okay. What does and so we just need to put self in here. Don't worry about self. Like I said, we'll learn about self when we get to the object-oriented programming section of this course. Okay. Now what we can do is we can do a self dot assert equal, and we can say we're going to call a function, probably called check product. And check product doesn't need to take in anything. Well, we said in the requirements for this feature is that it's going to take in a list of integers. So we're going to pass in a list of integers. And so a list is denoted with the square brackets. And so we can kind of check this out and see if it works. And let's throw some things in there. Let's say, maybe if we throw in 1, you can pick just random stuff if you want, but you should think strategically about these use cases. Okay, you should think strategically about it. And so right now I'm going to say 1, 1, and 5. Okay, and it will be on us to do the math to make sure we understood what the product of these three numbers is supposed to be. And we can say, okay, 1 times 1 is 1. 1 times anything else is the other thing. So 5, and 5 should be the value. This should be the product of all of the things that are right here. Okay. And so we can say, okay, we think that the value of this should be this, and a list can have as many numbers as we want. So maybe we want to check product here, and maybe let's add another one, or maybe let's leave that there, and maybe we want to write a new one that says test check multiply by 0. Maybe we want to check for the use cases of what happens when we multiply by 0, right? Because that's a little bit different. And maybe we want to do a couple of different ones. Maybe we want to grab this so we don't have to keep retyping. And maybe we want to say 1 times 5 times 5. Maybe we want to make an easy one first and just do something like 10 times 0. and we want to make sure that's 0. And so our first use case is to make sure that when the second item in the list is a 0, that the value is 0. But maybe we want to take this again, and maybe we want to make sure the same thing happens when we do the first number as a 0. And 0 times 5. Or 0 times 10. Okay, we want to make sure that's 0. And then maybe we want to do one last one where we are doing a bunch of numbers. And we want to do 1 times 1 times 5 times 392 times 67 times 0 in the middle times, this thing here times this. And all of these should be 0 if we write our code properly, okay? If we write our code properly, this should equal 0. As long as there's a single 0 in there, this whole thing should be 0. And so now, we checked some normal numbers, and we can write more of these tests right here with 3 digits. Maybe we want to do 2 digits, maybe we want to do 5 digits, whatever. And then maybe we want to do another one. I don't know, maybe we want to do, let's say test check product negative values. Okay, so maybe we want to see and make sure that our product is proper when we add in some negative values. So if we have -1, 5, and 5, then our answer should be -5. Since there's one negative number, then maybe we want to take this and we want to say, hey, what happens when we multiply together 2 negative numbers? And we do -1 times -8. And that should give us a positive number. Remember, 2 negatives equals a positive. So maybe we want -1 and -8 should equal 8. So check out all of these that we just did. We just did all of these that you can barely tell are highlighted. But we have a number of cases here that we're checking against. So we've done a normal multiplication right up top. We've done when you multiply by 0 and ensuring that the 0 gets set up properly. And we did negative values as well. So now that we have this, if we believe that we have all of our stuff, we can go ahead and write the code that we need to write. What's up, Excalios? Welcome to the channel. It is good to have you. What's up, Eric Demon as well? Robotic Head, welcome to the channel, my dog. Good to have you. Hashtag Friday. I'm sorry I missed it again. Thank you so much for the tier 1 sub. Thank you so much for the love. Hey, to the moon, man. To the moon. We're going to the moon. I appreciate it. Definitely appreciate it. So let's do this. So now, remember, we want to write failing tests first. So let's make sure we have written our tests properly, and they should be failing now. And this lets us know, hey, we gotta solve all these problems. Check product not defined. Check product not defined, because we have 2 different tests, really 3, and we have 3 failing tests currently. 3 failing tests, 2 passing tests. Why do we have 3 failing tests? Well, we have 3 failing tests because we wrote 3 different tests. And we can, you can put comments at the top saying what this thing is testing, but we have 3 failing tests right here. And now let's write our code to make this happen. So we write def. It helps because now we already we know what our function needs to be called. We know our function needs to be called check product. We already know. We don't even have to think of a function name. It's already been done for us. So check product. It needs to take in a list of integers. So it's going to take in one thing, but it's going to be a list of integers. And we can say our list, maybe. Sure. And that's going to be the placeholder there. And now we do have a passing function. Let's write in what we need. This is where we're going to start to use some of the tools. If we have a list and we want to return all the items in the list as a product, how can we do it? So if you wanted to do it in a one-liner like we did it before, you might think, your mind might automatically go to, hey, if you wanted to make the first test pass, you could say, okay, well, I'll multiply all those things together. They can be accessed via their index. And so you might say, all right, if I'm solving the first test case, I can go return our list 0 times, we learned about arithmetic operators, so we know how to do multiplication, our list 1, and you might say our list 2, okay? And because you're using your test to guide what you're doing. So this is perfectly reasonable, okay? It's perfectly reasonable for you to look at this as you're trying to iterate over this and figure this out. So you look at it, you say, I got 3 items here and I expect to get this output. Let me see what happens when I run this. And so you save it right here and you say, cool, let's go ahead and run it. And Because we didn't write it any separately, check this out. But we still have three failing things here, but it's actually, this is actually a reasonable solution. Check product takes one positional argument, but two were given. I think I put my comments in the wrong place. Yeah, hold on 1 second. It takes one, but I gave two. Sorry. The comma's in the, this is in the wrong place for all of these actually. Oh, that sucks. Hold on. Let me fix all these. That's gross. It happens. I basically passed in two things because of where my, because of where I close things off at. So that's how I pass in just one. So instead of passing in two things, pass in just one. So now this should be right. So that helped guide what I was doing wrong as well. But now check that out. It's only two failing now, but three are passing. So for one of them, now we have three little dots here. This is useful. This is a valid test for this one right here. This is valid code, but it does not solve the entirety of what we're trying to solve. Okay. Bpez, yeah, you caught it. I should have read your comments. This does not solve our problem. You know, it solves one of the test cases, but this is not, we can be confident this isn't proper code for what we are intending to happen, because it doesn't solve all the test cases that we created. And so you can say, okay, this kind of sucks. And you can say, all right, you can start to think, you can say, also, we don't even know how many items are going to be passed in. So it's tough to do that. What if we passed in 4 items? This would not work. So you can say, okay, back to the drawing board. All right, so back to the drawing board, and you can say, hey, how do I, you know, with an unknown number of items in here, how do I go through a list and add all the things together or multiply them all together? And that's where a for loop comes in. And you can say for, you can do a for loop here, and we can say for, you know, maybe you want to do for num in our list. And so this is a for each loop. Remember, you know, there's for loops, for each loops. Python, I think, only implements for each loops, maybe. I think that's what we talked about. But it's a for each loop. So a for each item that is in this collection. So our list is a collection. For item in collection. Go ahead and do something. And so maybe the best way. So we'll do this verbosely first. And so let's make a total. Let's make a product. You know, so let's set up a product variable, which is equal to 0. It starts out as 0. This is actually a pretty interesting thing for us to do here. But we can set it equal to 0. Fine. And so let's go through each item, and then let's oh, this is a good one. I like this. Yes, not at 0. Start at 1. Yeah, this is what I wanted you to see. And so what you could do is, because you want to multiply everything, you could say something like, you know, my current product times, you know, whatever number we're currently on, whatever item in that list that we're currently on. And actually, I don't know if num is an index or not, but we'll find out in a second. You can say equals product, or product equals product times num. So what it'll do is it'll take our product and it'll multiply it times whatever item we are on in the list. Okay. And so, you know, we can see that. And if you wanted to check it out, we know we need to return something, and maybe we'll return product and we'll see what the value is. We can also add in some things to help us see what's going on. So maybe we want to, you know, maybe we don't know what this is. So maybe at the end of this, we want to go ahead and print, not at the end, but after this, after we calculate it, maybe we want to print out the product and see what we have here and make sure things are going well for us, even if things aren't working. What's up, So Sorry? Welcome to the channel. Thank you for the follow. Good to have you. I did not make any dad jokes yet, silly boy. I'm working on it. I heard some good ones. I've heard some good ones lately. I'm not gonna lie to you. And so we can run this, and you know, check this out. It says our output is 0, 0, 0. No more are passing. And so you might say, oh no, everything I'm doing is defaulting to 0. If we make our product right here 0, it gets kind of tough to do because whoa, redo. Okay. Because anything multiplies by 0 is 0. So whenever we multiply product times the current item, it's going to always equal 0. So we got to make product 1. Okay. That's the safe way to do this. Make product 1. And now we can try to do this again and say, hey, all right, what are we doing? And just by doing this, now our tests are passing. Let's walk through what's happening. what does a for loop do? A for loop allows you to iterate over or for each allows you to iterate over a collection. So what it does is the first run. So a loop, if you're unfamiliar with a loop simply allows you to run some code, a snippet of code, as many times for as long as the scenario in which you create is true. So a for each loop will run as long as there is an item still to iterate through in the list. It will go through it. So it starts at the very first item in the list, and on the first run, it goes ahead and it takes product, which is 1, and it multiplies 1 times whatever that number is. So the first time, it's the number 1. So 1 times 1 equals 1, and then so it sets it back equal to itself. Now we can clean this up a little bit. After it does that, it's going to print it out for us so we can see it, and it's going to return the product after it goes through all iterations. So it's going to go through every item in the list, multiply it to the product, which is going to ultimately be saved as the product of as we go through each number, and it's going to get returned. We can use an assignment operator to do this. Remember, we learned about assignment operators, and instead of doing that, we can do times equals, or maybe it's equals times. I don't know. Does this work in Python? I actually don't know. Let's find out. Let's see if this works. PyTest, it still works. So we did a times equals instead of a, you've probably seen plus equals before, but we just did a times equals here. And so that's great, that works. We can also make this even cleaner. We can make this even cleaner. The product might still have to stay that way because the number is not 1, but it works, okay? It's completely fine, it works. This is a functional thing, it solves all of our tests. We can go with this. Your code doesn't have to be perfect, but as long as it passes what you need it to pass, it works. Do we need to initialize our list as an empty list? So yeah, if we wrote a test for that, we would. So right now, if we wrote a test that said, hey, you know, what happens if I pass in a completely empty list? Like let's say right here, I just did another self.assert, and we pass in an empty list, and we expected that product to be 0, or we pass in just something like this. What did I do? F open, nope. F open, there we go. Let's put an empty list in here. And so maybe, you know, let's see what happens when the empty list is passed in. We don't know, you know, let's see if it works. And it fails, okay? When we pass in an empty list, check that out. An empty list, that's a really good one. You see how I didn't think of all the use cases up front. When an empty list is passed in, which is legal to do, it comes back as 1 instead of 0. It should come back as 0, but it comes back as 1. Why? Because that's how we have it coded. You know, that's how we have it coded right here. And so you can do, you know, maybe we can do the same thing. This is a cop out. There are better ways to handle this, much better ways to handle this, but maybe, you know, maybe we just do this. You know, the default value is maybe this, but actually, no, this won't work. This will actually still fail. Why will it still fail? Because this is an actual thing that's passed in. This is still going to fail. This is not nothing. It is an empty. It is not an empty list. It is, we passed an empty list. It's a valid item. So you got to add some handlers in here. So this, you know, there we go. We caught a use case. Let's actually fix this a little bit, real fast. How about this? Let's say, this is so stupid. Maybe we only run, you know, this is just one way you could do it. What's up, Bedrock Michael? Thank you so much for the Twitch Prime sub. Good to have you for all the time. The Green Cereal, welcome to the channel. Thank you so much for the follow. It's good to have you. But maybe we want to do something like this. We could say, hey, if the length of this thing is CD, oh, this is actually really interesting. This is actually going to cause us more problems, actually, I think. But let's say, hey, if the length of what we passed in, of our list, if that length is 0, if the length of this thing is 0, then go ahead and run this code. Go ahead and do the for loop. I mean, wait, no. Actually, no, don't do the for loop. If there's no length, go ahead and return, whoops. Maybe we just want to return, just return 0. Right up front, we just return 0. Else, go ahead and do this code. And so maybe this works. Maybe this solves all of our problems. Maybe it does, maybe it doesn't. So now we've added in some new items, okay? Now we've added in some brand new logic to our code base now already. All right. And so let's just run it and see what happens. You know, we're just throwing stuff against the wall and this works. Yeah, it works. It works. And so to solve the problem where there's nothing passed in, we could also, you know, just set this equal to an empty thing as well, just in case no one passes in anything. And if we wrote a test for that, it would work. So yes, you can do a lot of stuff. Allow, I don't know why it didn't allow that, should be allowable now. But yeah, you know, you can do it. You can, you figure out what to do with it and you handle it accordingly. But thinking about those test cases is super, super duper valuable. All right. So that works. Man, I really thought we were gonna get through all three of these things today, but we'll get through all three of these, but I thought we were gonna get through all three of the problems that are in here. But yeah, can you check the first item on the list? So yeah, you can check the first item on the list, but there might not be an item in the list. And so you can check if it exists, which is, you know, a similar thing. I don't know in Python, I don't know the way that the interpreter executes this. I don't know it well enough to know if this is a performance hit over checking against the first item in the list or something like that. This works fine. Anti-pattern if links are allowed. Yeah, links are allowed. Share away. If it tries to block it, I will allow it. But yeah, I would love to. And so just throwing this thing out there, you know, just this led us to answering these things. Mutable default value, anti-pattern parameter append function under the append. List every time. Reality, that's not what happens. First time, no. Just call Python creates persistent list. Every subsequent call to append appends the value to that original list. Expecting 5, actual 5. Oh, interesting. That's very interesting. Okay, but that's actually really good to know. That's cool. See, these are things that I don't know about Python. That's interesting. Most listeners will learn about this. Excellent. We solved it. Again, like I said, it doesn't mean it's going to be the right code, but it does solve for the use cases that we want to solve for. I just threw an answer out there. Try to solve it in whichever way you want to solve that to make sure those test cases do pass. I'm going to create another piece of code for this last piece. Write a function that takes in a string and returns a new string with only the letters in the first and odd indices. Very interesting. So, yeah, I don't even know. I thought of this on the spot. Let's do this. It'll be fine. So let's go ahead and write some test cases for this. So def, test. I'm going to call this odd string. I'm going to call it odd string return, whatever. I don't know. And what this thing is going to do is it's going to take a string and return only the first. It's going to return a new string. That's really good to know. It's going to return a string with specifically the first indice and odd indices combined together as one string. So what you can do is this is very interesting. And actually, this will be very interesting. Let's assert equals, and we'll figure out our code after we assert this equals. And what are we going to call this? We need to think of a name, and let's call it odd. We'll just call it odd string, whatever. Odd string is what we do. And again, let's take let me take something like Aaron. Let's make a longer string. Let's say hello there, you. Great, phenomenal. And so yes, assert equal. We saw on that list. There's many more. We're assert equal in all the things right now, but there are a bunch of options on the list that will allow you to do some comparisons or help you out. We're gonna stick with this for now, just because like I said, it's a bigger topic to kind of get good at all these things. And so, hello there, you. What should this come back as? The output of this should be the first letter, and then all of the odd items. So not E. Oh, actually, no, E. E is at 1. So that should return. Then not the first L, but then the second L. Not the O, but then the space. Not the capital T, but the H. Not the E, but the R. Not the E, but the space. not the Y, but the O, and not the U. That feels right. I don't know if that's right. I could have messed that up substantially. What's up, NS9? Welcome to the channel. What's up, Orbitane Game? Welcome to the channel. Welcome to the channel. Thank you so much for the follow. This feels like something. This feels right. Maybe we should do an easier one as well, just to kind of, you know, make sure we got some things going. And let's just test this at first. Maybe we'll do something simpler, like yes. Yes, it should return the first item on the list, which is Y, and then it should return E because it's in the first index, but not the S. So that works. Why do we have H and E when H is 0, which is even? So the reason why is because the function, the feature that we're creating actually returns a new string with only the letters in the first and odd. And okay, interesting. Very interesting. That's a poor choice by me. First, when I said first here, I was talking about not the first index, but the first space, the very first letter of this, and odd indexes. So yes, the first index, actually the first index is still, well, I can get the confusion there, because if you say the first index, you might think I mean the one index, which is the second item. But let's say the starting letter and all odd indices. Okay, so the very first letter and then all I indices, So the very first one is 0. Yep. So, you know, that could be an issue with the way we talk about that. Okay, cool. So for this one, we should just get Y and E for that. And okay, what other use cases can we think about? Let's also think about what happens when we pass in an empty string. We should get an empty string. What happens when we, what else can we think of here? Oh, is my music done? What happened here? It did stop. Oh, because I didn't have it on. Okay, let's switch it up to, let's go synthwave. Let's go to synthwave playlist. All right. Yeah, that's fine. What if, let's do a random one. Let's do a, blank spaces. I like that. That's exactly where I was going with this, but I was gonna do where they were all, I like that. Blank spaces. 6, 7, 8. 8 blank spaces should return, 8 blank spaces should return the first one, index 0, index 1, index 3, index 5, and index 7, because there are 8 options. So it should return 5 items, I guess. Is that right? So 1, 2, 3, 4, 5. We'll see. Maybe I did that completely wrong. But yeah, you know, 7 by 2. So yes, there's a number of ways we can. I'm just thinking through how we can implement this. Let's take this and let's write some code. All right, so def, we said we were gonna call this odd string. It's going to take in a string, so we'll just, you know, say our string or something, just to make it super descriptive. And now let's do some stuff. So this is actually pretty interesting. We might need to check a couple things out. I actually don't know if some of this stuff works in Python, but one of the first things we can do is, we know that strings are our collection. They essentially are a collection. They are a collection of letters, right? They're a collection of letters. So what that means is you can iterate through them, and also you can look at the indices. You can use the indices for letters to determine where they are. So in Python, if I was to go, let me open up the terminal here. If I was to go Python 3 and learn how to type, and I were to set up X equals a bunch of letters like this, and I were to say print X at the index of maybe 5 or something, we would get the letter F here because 0, 1, 2, 3, 4, 5. The letter is F here. So that's, you know, we can start to do that. What happened here? How do I get out of exit this? There we go. And so we can use that in what we're doing. See, yes, n divided by 2 plus 1. We could use that. So it should only be 5. Okay, thank you. There we go. Then we'll make sure that that is 5. Instead, you can make your own index by incrementing it as you iterate through the elements of the string. We could do that. We definitely could do that. My guy doing Python? Yeah, I'm doing Python right now. We're hoping to do some Go. I might go through one problem after this, but we'll see how long this takes us. So, you know, a couple of different ways we could hop into this thing. there's like 10 different ways you could solve this problem. I'm actually just like right now, I'm literally thinking of the most creative ways that I could solve this problem. Yeah, a dumb way. I want to solve it in the dumbest way first. Well, not dumbest way. This might not be dumb. Let's hold on. I'm just thinking of create. I thought of how I would solve it first, and then I was like, you know what? Let me take a step back and see how I could solve it in different ways. Are these exercises from a book or from Codecademy? No, I literally made this one up before. I had a Codecademy one in here. The other two are from Codecademy, and I put where they're from. There are 2 more in this repository, Fibonacci and Hamming. We'll talk about those, but this one is just something that we kind of went through. These are, I posted a link to the repo for this. Here's the repo right here if you need it. And you can kind of go through this, but these are 3 individual functions that don't really make sense, but you know, a sloppy way. I don't know why I want to do this so bad. This is very interesting. Let's say X equals 0. Okay. Let's say X equals 0. No. All right. All right, so one way you can do this. Is to, maybe you could, you don't need to split the string, but you could split the string. It will be a waste, it'll be extra, and you could iterate through it and append these things to another list. You could also take it and you could take it as it is now, and you know you can iterate through it, and you can append these things to another list. And then I think does Python have a join? I'm pretty sure Python has a join. Let's see. I'm pretty sure you can join thing together. You can join together and it makes it a single string. I think that'll do it. So that's something you can also do, maybe. Let's actually check that out. Let's see what we have available. I'm just throwing stuff out there right now. Let's say X equals, now let's say it equals the letter L, comma P, and comma U, whatever. And then if we do an is this just a string method? So can I just do print x dot join? I didn't look at the usage of that. You know, we're just trying stuff out. Does that work? No. Let's see how to use the join. Oh, I gotta set it equal to something. Number. Let me see. Hold on. Let me see what this is real quick. Is this going to join? Oh, it's going to join it at. Oh, interesting. Okay, so let's go back to it. And we'll say y equals. Already forgot it. Y equals. This is gross. Actually, I don't like this join function at all. And then pass in x. Can I do that? And then print y. There we go. We did it. Very exciting. So yeah, we can use that, and you know, that's phenomenal. Very exciting. Okay, let's write something to do this. We could say we don't need to iterate over anything because we can take those spaces. We can say we can append this to we're gonna pin this to a new, all right. Maybe we do need to iterate. Maybe we do need to iterate through it. Okay, we can do a for loop. For I and R string, that should iterate just fine. What if I do real quick? Let's see if we can print I, and maybe to make it a little bit more clear, if I print out each letter, can I print out each letter in the string using? Does a for each work like this in Python? I don't know. Let's see. Feels like it should work like this. And if we simply do a PyTest, it's going to fail, but we should at least get it. Okay, great. So it prints out each of the things. So we can iterate through all of the letters. But that's not really good because the index is what we need. Will this change it to an index if I do range R string? If I do range like 0 to length of R string, will this now print out a number instead? I want letter to be an integer instead. Okay, good, we did it. I'm a pro. I'm the greatest who ever did it. 100%. Can we start off with an empty list? Yeah. Yes, we can start off with creating an empty list. No problem, and skip the first index. We could skip the first index, but we need the first index. So you could say, make a empty list called something like result. All right. So you could do something like this. You could say result equals, empty list, because we can start to build a brand new list. Ain't no profit. Completely understand. Got to peace out. Peace out. Absolutely, for sure. So yes, we could create an empty list like this if we'd like. No problem. But remember, we need the first item, and we need all of the other items. So maybe you want to start off like this, and maybe the very first thing you want to do is do something like result dot append, and what can you just append? R string 0. Okay, maybe you want to do that. I think that's how append works. Great. So we do need the first item here, and so the first item will get stuck in there, and we're good to go. So maybe now, the range function actually works from a beginning point to the end, but not inclusive of the end index. So we can actually start it at 1. We can actually do the append first. So now the very first letter will go in there, and then we can start our loop at the second item actually in here. And so if we actually start to append letter, it's not letter, it is our string letter, and we use the actual index instead, this will start at the second letter. So now if we go back to this, it should start at, see, it didn't print the H in hello. So it started at the E, which is good. It started at the second letter of what we're doing. So we append the first letter, and then we go through the length of the thing all the way up to the end. And what we can do now is we can do result dot append, and we simply append. We don't want to append everything. Oh, this is actually perfect. This is perfect. Because we're using the range function has something called a step. I was gonna implement some logic in here, so we could do this. But then what we would have to do is we could say something like this. We could say the kind of standard way that you might think to do this is you would say, hey, if letter, because letter is an index now, you can say, hey, if letter modulo 2 equals 0, we know that means that means that if it's evenly divisible by 2, it's an even number. Then we can say, hey, don't do anything. We can say, hey, go ahead and continue and just go on to the next iteration of the loop. Else if it's not equal to 0, then go ahead and you can do result.append. Result.append, and simply append on our string at the index that we're at. And the index right now is letter. Okay, and whoops, result.append. Okay, and then we will get to the very end of this, and we will simply return our result. All right, and so I'm gonna run this, and then we'll go back through it more slowly, but I'll show you what's happening in a second. We could do this. That's something we could do. I can't keep up anymore. Got to switch and watch and try later. Absolutely, Penguin Airlines. I absolutely understand. So we could do this. This is one way, and almost. And this might have to do with the way that we did this assertion. Oh, we didn't actually do the join. We didn't do the join here, but it looks more like what we want. And so we need the last thing is we need result equals this dot join on our result. Okay. And I think this is going to give us what we want, but we'll see, and we'll break it down in a second. Almost, it did not return result equals. It didn't do it. Why didn't it do it? Why didn't it actually do the join for us? Oh, because again, I spelled something wrong, as I normally do. You know, I should always just assume it's spelling first and index out of range. So this is good. We get another problem. It says index out of range, which means it's trying to go past where we want to go to, and check that out. It says, hey, when this is only for the last item. This is only for the one where the thing is empty. When our string is the quotes, and it's because it doesn't exist. And so we can do something like this. There's a lot of ways we can handle. There's actually a lot of ways we can handle that. So this is a problem. If there's nothing, this is another thing where we can do. This is not what you should do. We'll implement the same kind of stuff that we want to do right here that we did up here, and we can say, hey, if the length of our string is 0, then go ahead. This is the worst way, but I'm only showing you this way because one, we haven't learned about error handling, and I don't want to dive too much into the intricacies of why this might not be the best solution. This works. So if length of our string equals 0, simply return this string right here, and there we go. That's all you need. You don't even need an else. Why don't you need an else? Because return will get you out of this whole function anyway. So we'll just do this. It's gross, but it works. Okay, let's look at what's happening, and then we'll make it a little more, we'll optimize it. So what's happening is it comes into this function. We set a result equal to nothing. What it does is it checks how long our string is. If our string is not 0, if it's greater than 0, it will, if it's actually 0, that means the string is an empty string, and it will return nothing. Okay, it'll return simply this. A return exits the function. A return immediately breaks out of the function and returns this data back to where it goes. So none of this other code will get run. That's why we don't need an else, because if it hits this return, we no longer need an else because it'll exit the function. So if this is not, if this isn't true, it'll go past this, and then it'll implement the logic that we want. It'll take the first letter in the string, add it to our result, then it will loop through the rest and add it to our result accordingly. Okay, everything passes. This is gross. There's an easier way to do this, so that you don't have to do this logic down here. The range function says, hey, count up from the starting point, which is 1, all the way up to the ending point, which is the length of our string. So if our string has 5 letters, the length will be 5. But we also can do something called a step, and we can tell it how many to count by. We can skip by 2s, by 5s, whatever. We're starting at 1, so we simply do steps of 2. If we do steps of 2, we don't even need to do this logic down here. We don't need to check if it's evenly divisible. We're starting at 1 and we are counting by 2, so it'll go 1, 3, 5, 7, 9, all the way up to this, but not including it. And so we can take this, and actually we might need to include it, to be honest, but let's see here. We can actually take this away and not actually do any of this, and simply just append. All right, and this should also work. This should give us the same passing thing, and it still works. It works because we just implemented a different tool, a different methodology to do it, and it made it a lot cleaner. And this has to do with your understanding of the range function. It's okay if you don't know that. Range, again, it takes in a starting number. It counts from a starting number up to, but not including an ending number. And the last one is a step. The step is optional. Actually the second and third thing are optional, but the step is optional, and so it'll go by twos. If I add 5 there, it'll count by 5s rather than 2. So it's the amount of steps there, and we still get what we want right here, and everything is good to go. Okay. Yeah, there we go. And yeah, that's that. Now, one thing so 9/11, let's take, I'm gonna push this code up for anyone who wants it. But real quick, we're gonna hop in. So this is test-driven development. Again, the understanding of tonight is simply test-driven development. Write your tests first. What we're practicing is unit tests. Remember, unit tests. We are testing a small unit of code. We are testing in each of these. We're testing a very specific unit of code in each of these, and so each test that we wrote is testing a very specific thing. That is what a unit test is. Great. Very quickly right now, I do need to go, but very quickly, we're gonna run through very fast this Fibonacci sequence in Go. Actually, no, not the Fibonacci sequence. We're not gonna run through the Hamming. No, we'll save this. I forgot we have a whole week of this. Never mind. Cool. That's your introduction to this. We will spend all day. We'll spend the entire time on Wednesday, and we kind of did today, but on Thursday, on Thursday, we will spend the entire time going through exorcism problems. So I have some other things in here. I gave you one exorcism problem for us to go through together. I copied this directly from exorcism, and it already has, and I'll give you an introduction to it a little bit. Exorcism practices test-driven development, and what it has here is, don't worry about knowing what Go tests are, and this can be confusing to look at. But what it does is it gives you some test cases, okay? So there's these cases test.go, and it gives you some test cases. And basically, it gives you some inputs and some outputs, and you can use that to check to figure out if the things that you're doing are good. And so we're gonna be able to work through these problems next time and go through them. That took much longer than I expected, to be honest, but we'll learn how to do that. And then you'll be receiving exorcism problems weekly, at least one exorcism problem weekly, aside from the other things that we're gonna be doing on here as well. So tangible takeaways, simply that you understand what test-driven development is. It is being able to write code to be able to test the code that you are doing. So one, you should still be writing tests even if you're not practicing test-driven development. You can write your functions first and write your tests afterwards, that's fine. But test-driven development in particular is writing failing tests. You write failing automated tests before you ever implement any type of any pieces of your features, and then you begin to iterate and write code to make your tests begin to pass. That is the goal of test-driven development. It's really designed to help you think deeper about solving your problem, and to help you think about all of the scenarios you need to account for when you are developing your solution. Great. Whether or not it's more beneficial or not is up in the air, but it's a methodology for practicing this thing that a lot of people do. And you want to know about the different pieces of testing. Unit testing, where you test a specific unit of code. Integration testing is where you're going to be testing what those units of code do when they are put together. And then we have other testing, regression testing, where you're making sure that things that were already working have not broken, things like that. We talk about automated testing versus manual testing. Manual testing is clicking around, doing things completely manually, checking, putting in inputs, checking for outputs manually, whereas automated testing is the writing of code to do these things for you. There's also automated manual testing, where you can automate the manual processes that you would do to manually test code as well. But yeah. Can you throw a link for Go? So Burning JC in the classroom, I throw a link for Go itself or Go tests. So in the classroom, it should have dropped a video actually. Oh, it didn't even drop. It's scheduled for tomorrow. Let me drop it now. I timed it wrong. Hold on, let me change it to right now. Oh, let's not schedule it. Let's just posted. There is an intro to testing in Go if you want to check that out and you want to try out some problems before we hop into it. We will only write Go on Thursday. But there's a video to kind of get you started with Go testing as well. It's a little bit different. There's the concept of structs. There's gonna be a few concepts in there we haven't covered yet, but hop into it. Have a good time with it. Like I said, you can try out one of the problems that I put in the repository right here. There's also another one where basically we're going to do the opposite. So we talked about TDD. This Fibonacci sequence one, I was going to have us do the opposite, where we implemented the code first and then wrote tests for it afterwards. And then we will do the Hamming one next time. These are interesting problems. What's good about these problems as well is like, these are going to be things that you have to think about, like both Fibonacci and the Hamming test one. You have to begin to really think and break down the problem, Hamming in particular. And so we're going to learn how to break down these problems and stuff starting this week. Well, we'll be doing practice problems to the end of this. When we get to the end of this, you may not know how to do all the algorithmic data structure problems and stuff, but you will know how to approach these problems, and you'll be able to get started on exorcism. You'll be able to get started on code wars. You'll be able to get started on all those things. You'll also be able to tangibly understand how to implement a lot of these things for actual projects. Like, these coding challenges aren't necessarily what you're going to be doing. You're not going to be implementing that type of code always when you are actually coding things on a job. So we'll also have more practical things than those, but it is helpful just to get started with those, because it's a lot easier to find those and to practice those than it is to find a project that you can actually approach at this point in time. So yeah, we'll just hop into all that. So it should be pretty fun. Lambda in Python, yes, it's just an arrow function like in JavaScript. It is, absolutely. So what's up, Jamal? How are you doing? You went from barely low. So first off, we talked about jobs. I've given them some stuff about server. First off, good to see you, man. Hope everything is going well. I might hit you up because, you know, I might hit you up about some stuff, but welcome, Jamal. Me and Jamal used to be coworkers at my very first job ever. Yes, went a long way from just knowing a little bit of Linux and Servant, and now I'm teaching Python. We're also teaching Go here, man. Go is my preferred language, and that's what we would like to, I would like to write more Go than Python. But yeah, what's up, man? Hope you're doing good. But yeah, so difficult to find a 5900X and a 3070. What's up, Thug Muffin? Like I told you guys, you know what? Actually, hold on. Well, I don't mean to, like I said, I just, when you bring it up, just got to flex on you a little bit, the little Strix 3090, just, sitting casually by the desk here. Still haven't decided what I'm going to do with it. Really haven't. I also have a 5800X. I actually don't have the 5900X anymore, just so you know. The reason why I don't have the 5900X anymore is because I wanted to play less games. This year I need to stop playing games because I need to run my business. I'm also having a child. And so also for content creation, the 3950X was better and it was cheaper. So yeah, that's what I got. So, there's a 3090, it's gotta fly. But I might actually build a secondary. I have enough pieces to build a second computer to take to the office. I just don't feel like I need this in both. But yeah, I've done good this year. In 2020, I've barely gamed at all, and it has paid off. Like, I'm actually getting things done, but I hope to get to the point where I can game. I love gaming. I'm going to find a place to insert gaming back into my life, but I needed to start the year off right and go as long as possible without doing it to make sure I can get some stuff done. But yeah, that's everything. That's everything. To be honest, I thought about the 3950X. Okay, so Doug Muffin, if your goal is to game, there is no comparison. The 3950X for gaming is super trash in comparison. The 5800X in the 3090, I'm not joking, I was getting like 20% more frames than I was with the 3950 and 3090. It is much faster. It is like the 5th generation is so much faster for gaming. It is so much better for gaming. But for content creation and stuff, like, those cores really help a lot. And so, I ain't tripping about it. But if you go this gaming, the 3950X is great. Don't get me wrong. The 3950X is great. The increase in speed you'll see though for 5th generation it's not nothing. And maybe it changes. I don't know what you game at. That for me, that was both for 1440p gaming and for 4K gaming. Like for both of them, I saw significant increases by switching. I would go for cores over gaming any day. Yeah, I agree. That's how I feel now. But you know, I have 4K monitors. I have 4K gaming monitors, but they're mainly for content creation. But I have 4K gaming monitors, and being able to get, when you're used to 144 hertz and then you go to 4K and you're only getting like 80, being able to get like 110, 120 is so much more beneficial. I don't know, it's crazy, but you know, if I could ever get a 5950X, I don't even think they exist, to be honest. I've seen one in the wild. I would get one, but right now I'm not spending no money. I'm not doing, you know, I had my run. I've had a good time, and it is what it is, you know. But I have this. This was too hot for my current computer. This was causing too much heat. I have the Founders Edition in there right now, and it works well for me. You know, I don't need a 30. I've learned that I don't need a 3090, but I want to do things that where I do need it. So one day I'll figure it out. I'll definitely figure it out. You can't get PS5s, man. I know you got the hookups on PS5s, man, but I can't get it. I don't know where to go. I am interested in grabbing a console, since, you know, when the baby comes, you know, if I'm, you know, we're relaxing, we have a big couch, and let the baby sleep and maybe get in an hour of gaming or something. You got 4 so far. I saw you got one for Gilbert. That's pretty dope. I was a little bit jealous. I'm not gonna lie. If you find one, let your boy know, or however you're doing it, give me the secret. I would love to grab one if I could. One PC for gaming at work. So what I might do is, instead of doing that, I might just build that other PC to not be a work computer and simply connect this to my TV downstairs and use it as like a Steam box. Seems like a waste, to be honest, but we'll see. Oh, Eric.dev. Space heater is not even the word. I have my window open right now because this room is little. It puts out so much heat, like an absurd amount of heat. But you know, in the winter it's nice. But I'm actually pretty worried about the summertime. But it'll be all right. I'll figure it out. It'll be okay. I don't even game want anything on that machine. Exactly. So my PS4 for in 2K15 or something. Hey, you gotta do what you gotta do. Got what you gotta do. So the Ryzen 5 3600X and the 5600 XT, hey, that's a build right there. The Micro Center by me gets a lot of Ryzen 5 5600Xs, and I've been tempted to pick them up for people. Maybe if I do see them, I'll grab them. I'll put out little feelers. People want them. I'm not a scalper. I'll never upcharge, but because I live next to a Micro Center, a lot of people don't live next to one. I go there pretty often. I'll find any, I'll grab them and let people know when I have stuff. Just be, you know, help people out in the way I can, because I didn't realize pickings were this slim. As someone who is by a bunch of Micro Centers, I didn't realize pickings were that slim. I also realized even the Micro Center in Pennsylvania is only like an hour and a half from me. That's kind of far, but like it's not crazy far. So, you know, I got some options. I got 4 within an hour and a half, 1 20 minutes away. I don't need a heater in my office. You live in Florida. That's very fair. I completely understand that. Yeah, so BPAS, I 100%, I completely understand. I'm not gonna stop playing video games, but for a period of time, I am going to stop playing video games. Also, first off, shout out also to Eric.dev. If you all ever want to learn anything about Azure or Docker or Go, Eric.dev does a lot of amazing stuff right here on Science and Technology as well. Does some pretty amazing stuff. Definitely check him out as well. Good to see you. Happy New Year. Cool. That's it. I'm done for the evening. I'm going to go get some food, relax with the lady and the baby. And, you know, I actually need to do some cleaning up and stuff. You know, life's hard. It's not hard, but also, you know, when you want to play, when your desire is to play some video games after you've worked all day and you got to go do some work, you know, it kind of sucks sometimes, but you know, it's life. I can't complain at all. Go throw on some good music, get some good food, you know, dance around the house while I'm cleaning up and stuff. You know, it'll be great. It'll be great. But that's it. Let's see who's online today. Oh, actually, let me push this code first to GitHub. Let's make sure you all have access to it really quick. I typed that incorrectly. I'm going to, instead of adding, I should just add a, the right thing to do would be to add a git ignore, but I'm not going to. And I'm just going to remove all the things I don't care about because we'll come back here later. I'm gonna add everything. TDD solutions added and git push. There we go. Now you have access to it. Like I said, I'll share this one more time for you in case you need the URL. It is here and you can grab it and we will update it. We'll update it. There's nothing wrong with the Git UI, high tech redneck. Nothing wrong with the Git UI, just, and actually the Git UI can be more beneficial sometimes for helping you understand what's actually happening. Nothing wrong with it. I do encourage everyone to learn as much command line stuff as they can, but hey, you know, if you can get by with it, you may not always have access to it, unfortunately, but you know, if it works for you, it works for you. I'm not a tool snob. I'm not a command line snob at all. You know, use what works to help you understand the concepts. The concepts are important. You could, if you understand how Git works and how to do stuff in it, you can look up the command that you need on the command line. Okay, ain't no big deal. If you understand what's going on, you can figure out what to do. The tool doesn't matter if you understand the concept. But who are we gonna go over and see today? Let's see who's on the line. Techno Tim, we've raided Techno Tim. Let's raid someone else. You know, we've been with Learn with Leon before. We're doing coding tonight. Learn with Leon doing some coding. Usually he's doing some JavaScript, but Learn with Leon is dope. And I'm just gonna raid him because I want to see him get over 400 because that's kind of cool. I actually don't think I've seen anyone in the Science Tech channel besides maybe Lana over 400 if it wasn't some kind of special event. So that's pretty cool. So we will head over there to make sure. Oh, and he's doing objects. That is actually great. So we'll head over to make sure, you know, you can get there. JS objects, that's pretty dope because objects are good to know. Let's see. Learn with Mr. Leon. All right, and so when we get in there, please spam some. If you have my emotes, please spam some of my emotes because in 2020 he rated us maybe twice, and his emote was used on this channel more than our emote was used. And so maybe, just maybe, if we rate him this time, we can spam him with our emotes, and maybe next year when the year's up, we will have gotten the most uses out of emotes on his channel. And we'll be pretty excited. But we're out here in 10, 9, 8. Thank you everybody for another great session. Keep an eye on some other things. If you're interested, tomorrow we're back with pipelines. I don't remember what we're diving into tomorrow, but if you want to learn some DevOps, infrastructure, SRE stuff, head over there. You can come through, and you know, we'll have a little bit of fun. So peace out, everyone. Have a great night. Oh, he's leaving. We'll catch him.